They've been auto-generating meeting notes, which is
That's so
pretty nice.
All right, now that we've already read out all of our private keys, let's get started.
The ceremonious reading of the private keys. Test, junk. Okay, let's jump right into this mofo. But first, like, just how I want to do this, because we've had on the order of like 75 comments. Thank you for all the emotional labor that goes into those comments. But because of that, I've tried to resolve as many as possible and actually work it into the content. And I think people probably know what their like comments were and what they're most concerned about. So what I want to do is like just jump to the pieces of content that I know people are going to have comments on, and we'll focus on that rather than like going through comment by comment. Also, I've scheduled this for half an hour. I fully intend to go long, and I'll be here as long as like it takes. But it's scheduled for half an hour, and I'm sure that like some people will not be able to stay for the whole time. We're still going to move quickly though, and even though we're going to go long. So I actually want to, although most of the comment, where I'm going to go is to this single superchain proxy admin. This is something I actually have gotten probably surprisingly little feedback on, but it is, so it's a big change and I want to talk about it. So right now, every OP chain has its own proxy admin. And this proxy admin is a contract that nicely abstracts away the differences in our different proxies. We have like 7 or 8 L1 contracts, and 2 of them have their own special proxy implementations with even unique interfaces. So this L1 proxy admin tracks the different addresses. So it says, okay, I know where these, especially like I know when you're trying to upgrade one of these 2 special non-standard proxies, and I'll abstract away all of that like uniqueness for you. That's really nice. However, we have one of these for every single OP chain. And then there's also a specialness about the OP mainnet, which is that it also handles our shared contracts like the superchain config and protocol versions. So I consider it to be a lot of technical debt to the point that it becomes dangerous. However, it's also dangerous to transfer ownership of every single proxy to a new contract. So we need to do that very carefully. The contract that I'm proposing is called the superchain proxy admin. So there's only one proxy admin. It doesn't actually know about, like, it's not going to crack the proxy types because there's only 2 proxies per system. We can be smart enough to say, okay, this one is the Chugsplash proxy. I'm going to call upgrade Chugsplash when I am upgrading the L1 standard bridge, and I'm going to call upgrade and call like upgrade resolved when I'm upgrading the resolved delegate proxy. I think that lays it out. I'll open it up for questions now. I know that was a big dump.
What did you say the approach was for the ownership transfers?
I want to do it in the OPCM, or possibly even like a one-off. I want to do it in an OPCM, and I think this might actually be its own upgrade, like an OPCM that just does this thing, and therefore does it atomically and can assert that all of the transfers happen safely, and revert otherwise. Go ahead, Kelvin.
Can you clarify exactly why we're doing this instead of just keeping the existing proxy admin? What's like, is there any, like, what's the downside to keeping the existing proxy admin?
That's a very fair question. I think that it's something that will become, so as we add chains, it will become more and more. So there's some gas cost inherent there, like there's extra S loads, there's like an extra and it's an extra contract to track. And then there's also like, I dislike the difference that we have with having like an L1 proxy admin for the shared contracts. I think that like I think it's clearly technical debt. It's something we wouldn't do if we were to be designing for a super chain system from the get-go. And so I'd like to address that technical debt now. If we're ever going to address it, we should now. If there's just significant trepidation against this, I think that's why I'm focusing on this, because it's something that I anticipate pushback on. And so, what do you think?
I'm like worried that this is loading the scope a little bit of an already very complicated thing. Like I mean, if we didn't have this, what does the upgrade process look like? Like, maybe what I'm trying to get at is that let's say that we're okay with whatever, it's annoying, but let's say we have one proxy admin per chain. I mean, that's one question, but also, I mean, the other thing worth considering is, can we just have one proxy admin for everything? Like, does it need to be a super, like, can we just use the same proxy admin for everything, right? Instead of having this special contract. But let's say, for the sake of argument, that we that instead of having that we have one proxy admin per chain. What is the, like, does that significantly change how the upgrades could work at all? Or like what impact would that have other than just the tech debt of having one proxy admin per chain?
So the proposal is don't write any new code, but throw out the existing, but like move to a single L1 proxy admin. Yeah, so I guess there's like three options here, right? It's like option number one is what you've presented, which is writing this new thing. Well, actually, let's go the other way, right? Option number one is do nothing. Go with the status quo. Each chain has its own proxy admin. Option number two is keep the existing proxy admin code, but just move to one unified proxy admin for everything, right? So like all the chains are owned by this same proxy admin, which then we own, instead of we own 10 different proxy admins. And then finally, this other thing of writing new code, right? Yeah. So I think I personally don't think like writing this new code is a big lift. I guess I don't. Yeah, and so I think the big decision is transferring, is like, do we undergo this operation to transfer everything to one contract? And so, yeah, personally, like I don't feel like. Sure. So let's say, so the big question then, the argument is not, let's ignore the writing new code thing, because let's say that that's cleanup, we can decide to do it or not. Yeah. So then the big question mark then is, presumably for chains other than OP mainnet, everyone is, well, okay, regardless, if we're writing new code, then for all chains, but if we're not writing code, then for chains other than OP mainnet, we are transferring ownership of all of these things to one contract. This one contract is the benefit here really, like, can you describe the benefit beyond just there are fewer contracts to think about? Is that the key benefit, or are there things that we can only do if we do it this way, right? Are there things that we can only do if we do it this way? Or are there like simplifications that we can make, sure.
Like, is the upgrade thing, is this like a leaky abstraction where, like, because we have more contracts, the more contracts is going to now impact the upgrade process? Or is it the upgrade process is agnostic to the more contracts, and it's just, it doesn't change the upgrade?
I think I have to check does anyone know offhand if the system config tracks the proxy admins in its addresses?
It does not. Yeah, it does not.
I mean, we can do that. We can add it to the addresses struct. I do think that it's like easy to say, oh, it's just one more contract to track per OP chain, but like we're like up to 7 or 8. I think it would be really nice to have like the like willingness to pay down to like reduce complexity in that sense. I know there's other hands up, so go ahead, Mark or Clabby.
And you're
Yeah.
first, Clabby.
Cool. So yeah, I mean, I think that like, John, you mentioned this, but this is really kind of probably our only opportunity to clean up this tech debt. Because like we're talking about basically launching, 40 to 50 chains in the next year. We're going to have to be tracking all of these proxy admins, and then also upgrades effectively become us having to either upgrade these implementations that proxy points to with like the double proxies, etc. So, I mean, I think that we could take this opportunity to have the proxy admin kind of be like a single step upgrade for the entire superchain. Like we've been going with this direction of basically trying to have people reuse all of our implementations. We can kind of just have like these double nested proxies where the global proxy admin just upgrades these proxies that act as implementation of each chain's contract deployment. And so like the prospect of, kind of having this thing that doesn't this upgrade path that doesn't linearly scale based off of the number of chains that we have inside of our dependency set seems great.
So my one thing here would be like, for the sake of like my personal input here would be, okay, let's proceed with unifying to a single proxy admin, but let's just make it like the existing proxy admin codes. We don't have to change anything, and then just make it also be whichever proxy admin is currently being used for OP mainnet. Like that to me feels like the safest thing, where we don't have to write any new code. Like it's slightly less, I mean, there's like some legacy stuff, but we get most of the benefit without without having to touch stuff. I mean, the proxy type like mapping is a little annoying. I mean, the
Okay, we don't have consensus. And so I'm just like, we don't have consensus. Maybe this is a new design document. But I don't want to block the conversation on this. Mark's had his hand up for a while, so I'll let him have the last word for now.
I think that it's a good idea to use one single proxy admin. Specifically, the value prop is reducing complexity with monitoring. There's one contract to monitor rather than n contracts to monitor. And when we think about monitoring, or when we think about shared security, the way that we monitor, if monitoring is part of our security model, then we like the more infrastructure that we have to run per chain for monitoring, the weaker the security model becomes, because you have like some sort of like chance of one of those, security monitoring infrastructure pieces failing.
Okay.
So that's the claim that I'll make. And I have a preference for not making an expanded interface and instead keeping the existing interface and just having the internal types mapping. And the specific value prop here is the person that is doing the upgrade script shouldn't have to care about the implementations under the hood. They should just be able to call. And it's kind of like the person that is deploying, when the chain is deployed, those mappings will get populated. So it's kind of like the lower level tooling, it sets it up to make it easier for the developer that is going to be like writing the upgrade script and it hides that abstraction from the developer.
Okay. I think we have consensus on this is worth discussion. And I see a few comments saying, well, let's move it into a design doc. So new design doc. Gonna jump to where I think I want to talk about modifications to L1 contracts. So apologies to anyone, like this has changed a fair bit in the last like 12 hours. And you might have even, I forgot to push some changes I had yesterday. So like this might not be what you last saw. If you are like, the word populator should not appear in this document anymore. Okay. So like, let's like remove that from our working memory. What I want to do, what I'm proposing to do to like existing contracts is fairly minimal. One, just use, basically put the initialized value into a consistent slot using unstructured storage in every single L1 contract. So it just goes someplace. We can use Open Zeppelin for that or not. And then we will continue to use a two-step upgrade process where every upgrade will upgrade to some contract which is purpose designed for deleting or like resetting the value in that slot so that that contract can be reinitialized. And then every L1 contract will also receive an upgrade method, which is like an initializer alongside the initialize method. So there will be two methods that can that will set the contract to initialized. That's like the whole thing. So I outline it all here. Maybe another detail is like, you know, this function will vary. It will take arguments depending. We'll need to be disciplined about resetting this function. This function will always be here. It will always have the initializer modifier. And after we make like upgrade the mainnet contracts, we need to detect that and reset this function. So that's a bit of overhead. But otherwise, that's the whole proposal basically is those two small changes to our existing contracts. Kelvin, go ahead.
Sorry, can you we say detect that and reset this function? What do you mean by that?
Yeah, like so the thing with this upgrade is that this upgrade method is that it's specific to like what you're upgrading from. So if you've already upgraded your contracts, then you don't want this function to still like set the bar value. The bar value has already been set. And so you need to like basically empty out the body of this function and remove the arguments. I'm gonna pass it to Mark because like he has lots of thoughts on this. So my apologies to Clabby. Go ahead, Mark.
Okay, I think that this is pretty cool. I like where this went. If we want to address the one thing that you said about how this upgrade function is like dangling after an upgrade, and we could, I still feel like pretty good about completely deleting both initialize and upgrade from the contract completely and literally just using storage setter in OPCM. If people don't like that, I'm fine with going with this. Just going to throw that out there. But on top of that, the one requirement that I think that we need is we need a storage slot that is an unstructured storage slot that represents the version. And then inside of the call to initialize, it would get set as like a version. And then inside of upgrade, it would require that the version was one smaller, and then it would increment it.
The goal there is like on-chain enforcement of like upgrade ordering or like not duplicating
Yes.
an action.
Like, I think the user story is just like a chain is too upgrades behind and it tries to call the latest OPCM. And then now it's broken.
Got it. So there has been a fair bit of discussion about that. Like another design review related to OPCM. Basically, we've agreed that we would do that off chain, and ordering would happen in the superchain registry. So like you want to do this upgrade, like this is the address for the OPCM from 2.0 to 2.1. And the reason for this is that Slipper likes this because we're concerned about like a situation where we have 2.0 and 2.1.0 and we need 2.0.1. So we need to like insert something in there because we've identified an issue and we need to be able to patch upgrade systems that haven't done that upgrade yet. Slipper, do you want to add anything to that?
Yeah, like if you have a chain of contracts that reference sort of the previous like upgrader, as it were, then it makes it impossible to change that chain without then having to redeploy everything. And it just makes things much easier from a like off-chain tooling perspective. You just know which addresses you need to call in which order, and then you just call them, as opposed to having to like, track a different lineage on L1, for example.
Okay, that makes sense. Okay, I'm bought into that. We had this problem when we went to reinitializer, which uses a similar pattern. So we hit this problem, and I completely understand.
Should we go to Kelvin?
Yeah, I
Sure.
think my other point is a bit too rabbit holey, but just throwing it out there. If people like it, then we can chat more.
Sorry, which other point did I miss something?
Just removing upgrade and initialize from the contract itself, and literally having OPCM basically do storage setter, and then setting the initialize or upgrade as part of storage setter step.
Okay, yeah, let's do that now. So couple thoughts. Right. So one, I think that your suggestion, there's two ways to take that. One is with the like abstracting the layout into a base contract, right?
Yeah, so there's one way to do it where you do abstract it out into a base contract.
Mhm.
But then the downside with that is now you need to deploy a base contract for every chain or for every contract. You're like basically deploying two contracts for every one contract. And like they both have the ability to know what the storage layout is. And one of them just does like minimal storage migration. And then the other one is like the full implementation. That's one way to think about it. Another way to think about it is always use storage setter and just make particular calls to storage setter that implement the initialize function and the upgrade function.
Right. So yeah, I think the challenge with that is that we have some weird things we do in initializers. Like we do a lot of checks in the system config, for example. So we're like, oh, resource metering, gas limit, like you need to be in these safety bounds. So we'd need to re-implement that in the OPCM.
Okay. All right. That makes sense. Okay. I'm not super attached to this idea. I'm fine with this.
Cool. Okay. Kelvin.
Can we go back a little bit and just reestablish what the problem statement is here? What are we trying to solve for? It's a little unclear to me what it is that, like, what are we actually trying to solve? What's the problem?
Okay, so I'd say two things. Like we need like initialization. We need this initializer pattern because we have upgrades. So we need we need some way of handling that. And so two-step was one is one option, or basically like you have two steps and the first step is like reset the initializer, or you do some reinitializer thing. And I think like, and maybe it's based on the SEMV, or maybe it's just based on like a number you write in. Generally, I think there's consensus that the reinitializer pattern is error prone and hard to manage. So
Sure.
that's one
we
problem.
Wipe the initializer slot.
Yeah.
Okay. So then the question is, I guess the second question is why not? I mean, I guess this is what you're trying to establish, but why not just run the initializer again?
Oh, instead of the upgrade function.
Correct.
Yes. Yeah. So the other problem that I'm trying to solve here is that that running the initializer again is like it creates. So one, you need to read the existing values in the contract and then reinitialize everything to the same value. So you're either going to do that off chain, which is like you're duplicating code, or you're going to do that on chain. It's going to be very expensive to like read every single value in the system config and resubmit it to the system config. It also removes the need. We have these weird edge cases in our initializers where we say, if this value is not 0, don't change it. Because like there have been situations in the past where so it is somewhat confusing to describe right now, but like you don't always want to reset a value, or like you have a race condition. The default sender, for example, we were if you were in the middle of a transaction in the cross-domain messenger, you could have a non-zero or a non-default sender and like reset it to that. So we have like a lot of issues in our initializers that like need to account for that. Sorry, that's poorly articulated of that particular problem, but I think that adding an upgrade function is pretty clean and actually makes it really clear like what the difference is that you're creating. Like there's a new fee admin on the system config. Also, it's going to be very rare. Like in most of the time, this upgrade function is going to be a no-op that just like says this contract was initialized. We almost only are ever going to do this on the system config that we add a new value, and then it's like it's clear that you're adding a fee admin and a chain operator fee admin or whatever it's called. So I think that is nicer than just like having an initializer with like side effects that are meant to not make any changes.
Got it. Okay, I need to think about it a little bit more, but yeah, okay, I understand.
Okay. Yeah, we're at time. Like I said, I'm just going to keep going until everybody drops off. Nobody has questions anymore. Okay, Clabby, you took your hand down, so go ahead, Mark.
Sorry, I didn't think we were talking. Yeah, I was just going to echo that. Like we also have this problem in the fault-proof upgrades quite a bit. Like you'll see that we use the storage setter to clear the initialized slot, but we also use the storage setter to set specific values rather than rerunning the whole initializer a lot of the time. And that I think is a lot messier than something like the upgrade function, where we'd be able to basically just codify that rather than put it as 4 or 5 extra transactions that we include inside of the bundle, just for the sake of not having to hit the branches inside of our initializers that we don't want to. Whereas like the difference is like separating these two and having chain, like the initial contract initialization be the initial contract initialization, and then have something else that you can change per version is just really useful in that regard.
One way I'd put it is like making a call to the system configs initializer is 20 lines of code. So this is like 20 lines of code that we don't need to put into the OPCM.
Wait, it's 20 lines of code that we don't. Wait, what is 20 lines of code? Sorry.
Calling system config.initialize, because you just you need to put all that stuff in there.
Got it. Okay, and then the upgrade function, we don't want to have version information there, right? Like previous version, next version type stuff, or it can be.
I'm open to it. Sorry, do you mean like we keep them, and so like every time we do an upgrade, we like add a new one? or just like
Oh,
some annotation on it?
I was just this is I'm not I do not necessarily think this is a good idea. I think it's like a relevant thing. It's like the first value that you pass in is the previous version of the contract.
Hmm.
So you like get the version of the contract first, and then when you call upgrade, you pass in the version automatically.
For what? For what purpose?
Just to add a require statement, require version equals this version minus 1, basically.
I think that
That's
go
like
back
what Mark
on-
was asking about. Yeah, like the on-chain version enforcement.
Yeah, I think that like gets into sort of like reinitializer territory and on-chain enforcement of ordering. So I think that's relitigation of a closed topic.
Okay.
It does get into though, like the idea of contract versioning. So this is a proposal to move the version, like to get rid of the version per contract for L1 contracts only, and just write that into the system config. And then we move to a world where we basically are upgrading all the L1 contracts simultaneously to whatever is in development. Go ahead, Kelvin.
Yeah. Okay. I mean, I guess you just right. The obvious concern there is that if it's it's this sort of this thing of like, if it's in develop, it's getting released, which is different from how we've imagined it before, right? Like what do we do? You know, like we have a bunch of stuff right now, for instance, in the, all the interop contracts. Like, what does one do in that world where we don't want to release the interop contracts because those are not like, is it, I mean, maybe the right way to think about this is that it's not the contracts that are in develop anymore. It's like the OPCM is the release, right?
Mm-hmm.
That's, and so it's like whatever goes into the OPCM is the thing. But it's like, so the contracts themselves don't really have I mean, I guess they do version, but they pull the version. I don't know. I'm confused now.
Go ahead, Matt.
Internet.
Yeah, I was going to say the way I would think about this is exactly what you said, Kelvin, where OPCM defines what's being released. So currently, what we do is we put out a release of the contracts, and in the release notes, we have to enumerate what's being released, because there's a lot of stuff that isn't being released because it's in development or it's non-standard or whatever. And we just have to enumerate all this manually. And so the solution here is now, instead of defining releases as a set of contracts and release notes, a release is a system that you can deploy and a system that you can upgrade to, both of which are specified by the OPCM contract. And so you put out a new version of the release, and OPCM has some global version in it, 2.0.0 or whatever. And you look at the OPCM code, anything that it deploys or anything that it upgrades to is part of that release. So the interop versions of system config interop would not be part of a release. And the data availability challenge would not be part of a release because they're not touched by the core OPCM.
Sure. I guess the interesting thing there is like, I still want this thing of like, given a contract source file, right? Like given a thing on Etherscan, what release is that a part of? Right? Given this source file, what release am I a part of? And like, even like, if you just send me a link on GitHub, I want to understand which release it came from without doing like a stateful operation to understand something. I want to understand, you know what I mean? I want to be able to like look at the code and see, okay, this is part of OPCM release 2.2.0, right?
So currently we don't even really have that. Like the contracts are versioned independently of the rest of the system. And so, you know, say we're putting out OP contracts 1.8 for Holocene, that's composed of system config 2.3 and optimism portal 3.12.
Yeah,
or
that's
whatever.
awful. That doesn't make any
It's
sense. We should
yeah.
get rid of
And
that.
so what you do currently is you go to your optimism portal, get the implementation address, and you look it up in the system in the superchain registry. And the superchain registry says, here's all of your implementations that compose OP contracts 1.8. And so it's the implementation address that you map to the broader release.
Yeah, so I'm just trying to understand if maybe there's an ideal version. Like, I'm trying to think from the perspective of an external user, what's the point of the versions, right? What's the point? What do people actually want, right? And what I would suspect that people actually want is, you know, they're looking at a specific piece of code, and like the version of a specific contract doesn't matter to you. It's kind of unimportant. It's only you know, which upgrade is this a part of is kind of the only question that actually matters, right?
Yeah. So I was going to say, like, even if we have version strings in our contracts, you know, malicious chain operators can lie about those version strings, right? And so any on-chain solution where you just say, yeah, this is version string 2.0, you know, a user can't just look on Etherscan and know that they're using the right thing. And so this is why we have to fall back to the superchain registry as the source of truth here. Because it's something that does tell users, okay, if this is the implementation address, now you know you're using the right governance approved contract. And so I think to answer your question, like the thing users want or that we're trying to solve for is, how do you know you're using governance approved releases of code?
Yeah, that's the key question. It's kind of.
So I guess like with that in mind, is there even really a need to expose a version function of any of these contracts on chain? Like if we're kind of doing this enforcement in the superchain registry, and I assume it's something around code hashes, like, you know, does the EVM ever really need to know that information?
You're saying, like, can we get rid of the version, any on-chain version altogether and just rely on the superchain registry anyway?
Yeah, because it seems like that's where we're doing our enforcement. Like we're basically saying, like, you know, how do we make sure that people know that they have the release that governance approved, right? And that's all enforced off chain anyway. You know, I don't think anybody consumes the versions on chain.
I mean, that seems reasonable to me. Like, you know, in the superchain registry, it'll say OP contracts 1.8.0, all of the individual implementation addresses, and the corresponding OPCM address. I'm curious what you think, John. I don't remember if we had a reason that we wanted it on chain. I can't recall.
I don't know about on chain. We definitely do use those sometimes. And I think it is useful.
Oh yeah.
Like, yeah. What is it? When is we use like upgrades?
Adrian had mentioned, I think it's the challenger that uses the version to know which ABIs to use.
Yeah, we've done this before. The off-chain
Totally.
stuff does too. So the client, when it was doing the transition between the two proofs, it's like the VM, for instance, to decide whether it's using an L2 output oracle thing or not, checks the contract version to do that.
What I would suggest is that the reason that we do that is because that's what the superchain registry exposes. Like you could just as easily compare against the code hash of an implementation, so long as you had a nice API that exposed that.
What would you compare the code hash to? Like the registry?
Yeah, like a code hash stored for the contract inside of the registry within the given release that you're looking for. Like, for example, when we switched over to fault proofs, we had to have all of our APIs effectively switched depending on the portal version because of an API breaking change. And so like in there, we compared it to the semantic version. But if we had some sort of mapping of release to implementation code hashes inside of the registry, we could have just as easily done that.
Could we have? Because then we would have to do a bunch of queries, right? You'd have to like.
I mean, it kind of
Figure-
depends. Like the code hash of a contract is one RPC call, just like the semantic version is. It's
Well,
just
to
not
get the
needed.
existing code hash, that's one thing. But then you need to ask, like it's easier for me to know to compare with semantic versioning of like I know that if it's before 2.0 that I use the L2 output Oracle ABI, and if it's after 3.0, or if it's after 2.0, I use the other ABI, right? Like that's easy. But like, how do I ask the question, what ABI should I be using?
That makes sense. Implementation details aside, it sounds like we do need some way to determine, what release the contracts are on, is what it sounds like.
maybe the middle ground here is let's keep the versions in specific contracts and continue to version contracts like we have been, but then really we're separately solving the more fundamental underlying problem, which is just like the real version is this, OPCM version, and asking the question of like, is this chain using the correct implementation or not?
Yeah,
But
I
for,
think like throwing out the Semver is like, I think there's two considerations. There's like, can we afford to get rid of the Semver? And it's like not clear what that breaks by like removing the version function from all the contracts. The other is like, how do we have a unified source of truth around what is in the release? And I think that this OPCM approach is inherently addressing it. And like, so we should also have an L1 contracts version, or is the L1 contracts version just the OPCM address and we don't need a number somewhere?
I think a number is nice. I
Yeah.
think that people like numbers. So I
Yeah.
would do both.
Okay. Yeah, like we're already numbering like 1.7, etc. Carl, go ahead.
I have to hop soon, so I want to be a little bit selfish. I'm curious, in the upgrade process, which is proposed.
Yeah.
Is there a is there reliance on on-chain data to then populate the calls that we are making, basically, like, or are we passing in basically all of the information required for the upgrade inside of the transaction payload? Like,
Sure.
the specific thing that I'm just trying to like, see is I just want to see if there's any sources of potential statefulness or otherwise non-determinism in the upgrade, and like where exactly are those sources of statefulness? Like, obviously the state of each contract we are upgrading is unavoidable statefulness, but if we can avoid some statefulness, for example, like if we're passing in the code hashes of every implementation, then that avoids some level of statefulness because we're not like passing in an arbitrary address that I don't know. That's the vibe question.
Yeah. Right. So that gets us to like this release process of media section that we haven't covered. As well as like you asked a question about like the use of delegate call.
Yeah.
So I think like I'll say like this is going to be a pure function that we should actually like use that strict like compiler functionality to enforce that you're not going to read anything and you have to pass everything in. And then I think it's also like a benefit of the upgrade function, because then you talked about the statefulness of the contracts themselves, like because we're using this upgrade function, which doesn't like impact on existing state. It's only like, it's an append only functionality. So I think that also helps to address the concern.
Cool.
I don't have anything to add to that right now.
Cool. So, okay. So basically what we're saying is the safe will delegate call the upgrade function, which is a pure function, which means that if insofar as it is passing in information, it is passing in entirely, all information sourced from like, call data. And then that upgrade function is calling all the other contracts upgrade functions, which is essentially, by kind of definition, the minimal set of state that you require for doing an upgrade. And many of the contracts, it will literally be a no op, and that is entirely fine.
Exactly. I think one
Cool.
edge case like that, if you got to drop at any point, I think like if you got what you need, that's great. One edge case I want to bring up while we have like Clabby from Proof's team here is that so something I didn't cover, but like prerequisite to this is the assumption that all contracts will either become MCP compliant or be shared. So like shared across all chains. The exception, like we're going to carve out an exception for the fault dispute game, which has like this pre-state hash dependency in it that is hard to address. So,
Yep.
but yeah, so basically means like I think delayed WETH and the anchor state registry will become MCP L1 compliant.
Totally. Yeah.
Cool.
So I'm not working on the proofs contracts much anymore, but there are some great proposals around making those contracts get to a point where they are shareable. Adrian has a chain registry proposal up that should help out a lot. And then also I think Kelvin and Copy Paste have been working on making sure that we can get those to a point where they're shareable. And also I think, by kind of definition, interop is going to help out a lot too. We're kind of probably going to think about moving towards like a shared dispute game factory and things like that. And I think all of that will kind of inform how we can make sure that these contracts don't exist as like the sole burden in that regard.
Cool. So yeah, I was going to say so I think then what we'll do is like, we will assume MCP compliance for everything but default dispute game, that being a bigger lift. I've seen Adrian's proposal. It looks like it's good, but for now, what we're going to do is for each chain, since it's going to have its own dispute game, we'll have to deploy those through our scripts. We'll deploy the like bespoke per chain dispute game, and then we'll use those as blueprints. So we'll basically like have to pass in the address for each one per chain, and then like do the needful to like orchestrate what is required in the for each, like the dispute game factory to update the implementation of the dispute game for each chain. Yeah, we also actually like, so just yammering on, we also are gonna, I don't know if I've forgotten to add it, but we will have an add game type function on the OPCM that will orchestrate this, because not every chain will have like the permissionless game on it. So the OPCM will have that as like an extra function for just adding a game to an existing system.
Okay, awesome. Yeah, that'll be super useful. I think the other thing too is we're probably going to be adding several game types in the next year. So the ability to do that easily will be really useful.
Nice. Go ahead, Matt.
I was going to ask, is there a difference between adding a game type and setting a game type, like when you just overwrite an existing implementation?
There is. So when you add a game type, you actually have to go into the anchor state registry and initialize the anchor state for that game type. But when going to the dispute game factory, it's the same call. You just set implementation on the new game type. There's just that extra setup step when you're first doing it.
Got it. So is the plan for OPCM to support only adding game types or also updating existing ones?
Every time we do a hard fork, we do need to update existing ones. So it'd be useful to have both, I think.
Cool. That sounds good to me. Thanks.
I'm super glad we recorded a transcript. It's gonna be very helpful. Anything else anybody wants to add or ask?
Is there anything else in this doc, or do we cover everything?
There's got to be more in this doc. Like I don't think we even covered this section thoroughly. Go ahead, Calvin.
Can you run over the upgrade controller stuff? Like,
Like, so I see that word here.
yes, like all like with this.
Yeah, like how it happens.
Like, wait, the high level logic for upgrading a contract. So I'm sorry, I'm just confused because this is you've written a contract here, but then also, like, is this actually a contract or is this just pseudocode?
Oh, sorry. This is the OPC. This goes into the OPCM.
I see. Okay. I see. Okay. And the upgrade controller, who is that? What is that?
That is like whatever. So in our case, it's the 2 of 2.
Okay.
But this is like meant to be like anybody can come. So say if a chain has a 3 of 3 multisig and is handling their own upgrades, then they can also use the upgrade function for their own chain.
Okay. And okay, yeah, I think this is fine. Never mind. All right. Seems reasonable.
Okay. Blaine?
Yeah, just on that, like 3 of 3 point that you made. What? So like more concretely, if we have a chain right now that is a 3 of 3, but we're saying that there's only one OPCM per release, so like, but every other OP chain has a 2 of 2. Do we need a separate OPCM for that one chain that hasn't moved to the 2 of 2 yet?
No, there's one OPCM per release, per new release. And so its whole goal, and because this function is like, so it should just like basically codify the logic required to move from version A to version B. So, and because it's being delegate called by a safe, it's, you can think of it as just a way of, similar to defining a bundle that is safe. So like where a safe executes a bundle is just doing, do this, do this, do this, do this. This should be thought of as basically like a way of writing the instructions for any given safe to upgrade any given chain, assuming it is on the correct like version.
Right. Okay. So I was for some reason thinking that we were going to have a modifier on this upgrade function that was like specific to the upgrade controller, but that's not the case, right?
No, I think like it, the auth lives in the system already. I don't think we need to duplicate it.
Yeah, that makes sense.
John, do you mind like just walking through the high level flow? Like, I think that might be where the confusion is here, because we would basically be delegate calling to this as a script instead, and so it doesn't have any privileges itself.
Yeah. So basically the way it would work is like we deploy new OPCM contract, which contains deploy and upgrade methods. And so prior to that, we would deploy new implementations. So there's like, we have a deploy implementations.s.sol script. So those will all get deployed to mainnet, and they will live in this like struct here. And so then, in shared config. So, like if there's shared config between the contracts that like doesn't need to be, or between the systems that doesn't need to be updated or like set per chain, then we can also like put this into here. And then for each, Yeah, and then this is basically like running through this loop. So, so I think I'll stick to this like implementation here. So this loop is going to go to each system config that's been provided. The system config contains a list of all the contracts in the system for that system config, and it's going to do the two-step upgrade approach that we talked about. It's going to reset the initialize slot, and it's going to call upgrade on it and call the upgrade function. And then we'll do like where there is changes to the dispute game contracts, then we'll handle that orchestration. It's a bit more. There's like, we're going to need to read the blueprint, deploy that, call set implementation to add that address, update the interstate registry, as Clavi mentioned. Let's see, and then coming back down here, yeah, that covers it all. There's a couple changes like we need to make to the system config. It needs to be able to give us the all the addresses in a single call, and we also need to add the address manager to that struct. But back to the flow. Are there any questions about the flow itself?
Would there ever be a case where you want to just perform like one chain's upgrade? I know that's a bit counterintuitive given this is like a super chain wide upgrade, but like, for example, passing in, well, I guess you could just pass in an array of one system config that contains one here, right?
Yep, that's how you would do it. If for some reason you had to do just like one chain at a time, that's what you would do.
Do we have any ideas? I mean, this is a detail, so we don't have to go into it here, on how we could enforce that this method doesn't read or write from storage.
The pure keyword?
Then you won't be able to execute calls because we don't know what the call would do, right? Because the calls are technically state changing.
Damn, you're right. Yeah, I was really excited about that keyword in the compiler.
Probably like it could do a slither sendgrep rule or something.
Well, how stateful is this contract? Like, maybe just not putting state in the contract is the answer? Is there
True, because
like,
then it would only happen if you drop into assembly.
Yeah.
That's a good thought. Like there should be no storage. And that we could do with like a static check pretty easily by just looking at the storage snapshots.
Blaine, maybe, like, is the deploy functionality more stateful, or is it mostly like immutables where data needs to be read?
Well, we have the blueprints, right, in storage. And when we create the OPCM, we have blueprints and the implementations. So maybe you have more details there.
Yeah, we currently do use storage, but we don't have to. Like we can just convert it all to immutables.
I think we should do that. I think like that just helps to clarify that, yeah, this is like it's a procedure. It's a procedural kind of like contract,
Yeah.
right?
Yeah, I actually think my latest change to OPCM, because we're using the constructor now, a lot of them are converted to immutables.
Cool.
I need to double check that though.
Still can't do immutable structs in Solidity, can you?
No, it's sad.
Oh man, okay.
It's so annoying.
I didn't have any like compiler feedback when I was writing this.
Oh, really? Maybe you can now then. I thought you couldn't.
Oh, I don't know. I haven't tried to my recollection.
So I'm catching up on OPCM and trying to learn how it works. But one thing I was curious about while I was looking into it last night, like, is there going to be a point where this kind of procedure that we prescribe that's like all on chain surpasses the block gas limit? That was kind of like my immediate worry is that it looks like it's going to end up being pretty expensive as it scales. Like what is the plan to kind of like scale out of that to the point that we may no longer be able to do a full upgrade in one block?
I think it'll get a lot cheaper when so to the extent that we have like carve outs for non like that we have to read a blueprint and like redeploy a contract, that's gonna be a big cost. This section is outdated because like just the process changed so much. But and so prior to having blueprints that get copied and redeployed, I came up with like, you know, back of the envelope 85,000 gas for the calls and the S loads and S stores that are required. Because for the most part, you're not like, oh, and using the initializer would like definitely kind of blow that out of the water with a lot more like no op actions. So anyways, I came up with 85,000. I tripled it to 250,000 per chain. So that gives us 120 OP chains. But yeah, while we're deploying net new like dispute games, it's going to be a lot more expensive. So I think that it's like something we have a lot of space for now. It's going to be a consideration in the future, and we'll have to kind of like keep an eye on it as we proceed.
Okay, cool. That's really good to know. Yeah, I mean, like, you know, I think that it's reasonable to assume that we can do L1 upgrades kind of staggered. Like most of the L1 contract upgrades that we do are, you know, kind of not time dependent. So not too worried, but that's good to know.
Yeah, I think we have enough time. We should have a test or at least a benchmark for this. I don't know how we'd have to read the registry and be like, how many chains are we upgrading and like multiply that. But I think that we should test it to like have an eye on that number.
Yeah, we definitely should for both the deploy and upgrade paths. This is like entirely slipped, but originally OPCM used to be over 30 million gas, and that's why we use blueprints and the identity precompile and all this stuff. And I meant to add a test in to check that it stays under 30 million gas. Never did. But we should have that test for deploy and upgrade for sure. I like your idea of doing it from the Superchain registry for upgrade.
Mm-hmm. Cool. All right. I think that covered it. Hopefully, next steps. I'm gonna have to like make some updates here. I'll pull out the section that we said basically needed to be its own. Actually, I'm gonna review the transcript. Unclear to me if we had like consensus on that or not. I'll try to drive consensus on that if I think we can.
For a Superchain proxy admin?
Yeah.
Got it. I think what we said in the chat, which I guess also gets recorded, I think, is we all agree on simplifying it, and then it's just the details we'll have to figure out.
So was it just
or
like
simplifying it into one contract?
Okay, so it's one contract, and then like, do we rewrite it or not?
Yeah, that's the open question.
I'm gonna give my 2 cents here. I think we should rewrite it. Instead of having like a bunch of different interfaces though, and instead of having the mapping, I think we should just use the code hash of the proxy. And if we just use the code hash of the proxy, then we don't need any like stateful configuration. We can always just load the proxy code hash and figure it out.
I love that idea in principle, but we also just saw how painful it was to like upgrade our Solidity version and such. And then if we ever want to move over to like the new compiler that's coming out and the code hashes don't match, like, you know, I just don't think it's super sustainable.
Only for the 2, like, do we publish new proxies? Do we ever use new versions of the
We don't, but
proxies?
we gotta compile them locally and such.
Yeah, so if you remember, like the way OPCM currently works is that it uses all the bytecode at the current commit. And so when it's deploying a new chain, it would deploy the bytecode for chug/proxy from the current commit. And so, like to Clavy's point, if we bump sol-c or change compiler settings, then OPCM v3 will deploy chug splash proxy with different bytecode than OPCM v2.
What about just like, I think they
But
probably
we
all
could
have a
change
different-
that.
What about the interface? Like instead of reading the, like, I think they all probably have a different function for getting the owner. And so like, could you just read the owner and see if it like,
Not on chain.
No,
Yeah,
you
the-
can't on-chain.
but
Yeah,
you
they have,
are
like,
the
Yeah,
owner.
the proxy has the indirection. You have to be the proxy owner in order to actually hit the owner function. At least on like the
That's it. I
1960s.
mean, there's like janky stuff you could do on chain for sure. Like
yeah,
you can
yeah.
pipe-
I
you
guess
can like
you're
hacky.
right, John. Like if we're delegate calling to OPCM, then OPCM is the owner.
Yeah.
And so
Another
it should
really
be able to read it.
Another really important thing to realize is that EOF is removing EXT code hash. So there is that. So you wouldn't be able to check EXT
Why?
code hash anymore.
why were they doing that?
Ask,
They're gonna
ask
have
it.
to. I think
Ask
they're gonna have to
ask
put all this
Epsilon.
back though, because it breaks like ERC 721 and stuff. So
Yeah.
I think they're gonna have to fix that. But either way, yeah, there's not. I don't know.
I mean,
I don't
is there any like? Because I mean, it'd be nice to not have to manually set these proxies in the proxy admin every time. Like, that's a huge pain to be able to do
Also,
that.
One thing
Yeah.
I'm curious about is like, does any other chain other than OP mainnet use any other proxy types other than 1967? Like we
Yes.
did really? Why did we? Okay, well,
Because that way it's a constant upgrade for everything. Like we're
Yeah.
not
Okay.
changing the, like every time you upgrade one contract, you have the same.
yeah. I
Upgrade.
suppose that makes sense. So we're stuck having like these three different proxy types. It sounds like.
I mean, we're kind of stuck unless you want to double proxy them and just like permalock the proxies to point at 1967 proxies.
Yeah.
That's one way to do it.
Well, double proxies actually sound like not too horrible, especially because like we already use double proxies for single transaction upgrades? I remember, John, you had a graph of this a really long time ago. I can't remember if we ever did that.
But no, we've never done double proxying. I think like it's just probably was the idea came up at some point.
Gotcha. I may have been misconstruing your proposal, but I still really like that proposal. Like it seems like it would
Yeah.
just really simplify upgrades.
We've talked about it as a way to basically have like a beacon pattern for upgrades. That way we don't have to upgrade all the implementations in a loop anymore. But I think it's something we can like revisit once we have gas limit issues.
Yeah. I mean, it is nice to not have to upgrade everything and just change the beacon once.
You'll still have to
Totally.
call all the upgrade methods though. So you'll still
Oh.
need a loop.
Nice.
Yeah, but I mean,
Boy.
if you're not time dependent, like at the very least, you have like you can get all of the implementations upgraded in like one batch transaction, and then you just have to go around and tell chain operators to dispatch their own upgrade function. And it can kind of be like node upgrades. Like you can upgrade your node any couple weeks before the hard fork activates.
I mean, look, how much work is it? Okay, whatever. We should have a separate design doc on this thing. If the amount of effort required to just set these proxies one time in this proxy admin on deploy the first time, and it's also only two proxies, right? It's like the one chug splash proxy and the one resolve delegate proxy that we still use, right? So it's like you set these two things one time on deploy and never think about it again and not have to audit a new smart contract and do this like whole thing would be nice.
Yeah.
So we would only double proxy those ones.
I mean, you could double proxy them if you want to double proxy those, where you don't even double proxy them into like this beacon pattern. You just permalock them into a double proxy where it's the 1967 proxy under the hood. And then you have the same interface for everything. That's like one thing to do.
Yeah, but then you have to like
I
track
think people
different addresses for each one. I don't know.
would also get really scared with permalocked proxies for those proxies, given that like they couldn't do some sort of recovery if there was a critical vulnerability. Like if you
Well,
permalock,
you could. You permalock it into being a proxy that's still upgradable.
That's super weird.
It's just like you just like can no longer. Yeah, it's super janky. Anyway, I think honestly the most realistic solution here is just keep the proxy admin as is, use the single proxy admin for everything, and then like, oh well, when you deploy the system for the first time, you just have to set these values once, right? Like, sucks, but whatever.
What if we publish an EIP to change our legacy proxy bytecode on mainnet?
Honestly, I would love that. Ugh.
That's super nice. Okay, but
I mean,
so just to confirm, we're good with a single unified superchain proxy admin. There's like, and the default is the existing L1 proxy admin code, and we just manage those proxy type mappings. And then if I want to simplify that or change it, new design.
Yeah.
doc.
Yeah.
Cool.
I mean, I think we should still have a design doc for this thing about moving to a single thing, just so that we can put this all on paper.
Yeah, the process is non-trivial. I agree.
So let's have two design docs. One is move to a single unified proxy admin. The second is, should we bother simplifying the proxy admin, right? And then we can argue about those two things distinctly and not have to, combine them into one big fight.
I would probably just, if I had to write another design doc, I would just like decide not to. I don't care that much about the source code of the unified proxy admin.
Fair enough.